Right here. Each one is 6. So we know each Reese's Cup package is 6. So 6 plus the pile of gummy worms is going to be 4. So I know this is 4. This is 6. So if this is 4, the Kit Kats have to be 16. Much better. Yes, ma'am. Much easier than the other day? Yeah, the other day everybody sat there and they glared at me like you guys were mad at me like no other.
I mixed up a plus sign and a multiplication sign.
Okay, I do think I have your lesson set 5s, but just in case some of you were gone, make sure you get lesson set 5 in. We answered some questions last time that we were together. What we want to look at today, you'll want a note card to talk about these consecutive integer word problems. Okay, we're going to look at what happens when I have decimal numbers involved in an equation, and then we're going to look at consecutive integer word problems. So the first thing, what if I ask you to solve that first problem? Do you guys like adding, subtracting, multiplying, and dividing decimals? So I could solve this problem the way that it is. Jonah, did you get those? Okay. So you could solve this problem the way it is. But I don't like working with decimals. So we can eliminate that. In algebra, we know it's okay. What you do to one side of the equation, you have to do to the other side of the equation. So if I look at this, I want to get rid of the decimals. If you multiply by 10, what do? You move the decimal once. So if I were to multiply this side by 10, I would use the distributive property, which means I take each one of those values times 10, but I'd also have to take the right-hand side of the equation times 10. But if I do that, you move your decimal point over one place, and you get 300x plus 4 when you move it over one place, equals 20.5. That didn't get rid of the decimals, did it? It got rid of one of them, but not all of them. So what we want to do is, what can I multiply by to get rid of those decimals? 1,000. 100 is going to move it how many places? 2. 1,000 is going to move it 3. Now here's the thing. You guys do not sit there and say, well, I can multiply both sides times 1,000, and then I use the distributive property, which means I'm going to do this. What you do is you go, what's the most number of places after the decimal point? What's the most number of places after the decimal point? 3. So you go, I'm going to move my decimal point 3 places. So this is what you do. You don't look at it as times 1,000. You look at it this way. 1, 2, 3. That makes it 3x. And then you're going to go here. 1, 2, 3. You got to add 2 zeros, and that makes it 400. You move it over 1, 2, 3, which makes it 2,050. Now, does that look like an equation you can solve? Yeah, what are you going to do? Move the 400 over by subtracting it. So you get 3x is equal to 1. Okay. 1650, then what do you need to do? Divide by 3. So if I divide by 3, I'm going to take 1650, and I'm going to divide by 3. 3 goes into 16 5 times. 3 goes into 15 5 times. Am I done? No. Please don't forget to put your 0 up there. So you end up with x being equal to 550. Now, I'm not saying it's incorrect to just go ahead and subtract 4/10 from both sides, but you have to keep in mind that when you are doing that, you got to line up the decimal point. So you put a 0, and you're going to end up with 1.65. For 7, 5 minus 0 is 5. 2 leaves 1. 10 minus 4 is 6. 6, and then you get your 1. But what you're not going to like is when you take that and you have to divide by 300, so you're not going to like dividing by those decimals because you're going to have 1.65 and you're going to have to divide that by 3 thousandths. Do you remember last year how you did that? You have to make the divisor a whole number. So you got to make that a 3. So you got to move the decimal point over 3 places. And now when you look at that particular problem, it's the same problem that you had right up there. So you can get there. It's just I don't like working with decimals. And I'm guessing you don't either. If you can get rid of fractions and decimals, math is a little bit easier. So we can use decimal equations sometimes when we look at this right here. We got to know how to read decimals. How do you read a decimal? Like, do you know how to read this decimal right here? 15 thousandths. You look at your place values, and the first place value is tenths. Then you have hundreds. Then you have thousands. So you read the number after the decimal point, which is 15, and then you put the place value of the last digit, which is in the thousandths place value. You like box diagrams, cross multiply and divide? This we can set up that way. It has it as a decimal. We could put it as we could go through probably and write it as an equation, but box diagrams. 15 thousandths of the teachers were either brave or completely fearless. So we have these teachers that are brave or completely fearless. How many of them? Not very many, right? 15 thousandths. That means only 15 out of 1,000 teachers are brave or completely fearless. So here's your total. 15 thousandths are brave or completely fearless. If 300 teachers fell into one of these categories, so how many teachers are there? 300. They want to know how many teachers were there in all. What do? Cross multiply and divide. What are you going to multiply together? 300 and 1,000. And we're going to divide by 15. So I'm going to take 300 and I'm going to divide by 15. 15 goes into 30 twice. So I end up with 20. And if I take that times 1,000, you get 20,000 teachers. Question? Gotta make sure you know how to read the place value. What about this one? An analysis of the old woman's utterances showed that how do I read that number? 932 thousandths. So 932 out of 1,000 were artisanal. If she spoke, so this is how many total words she says. Or utterances, I don't know if you want to do it as utterances. If she spoke 2,000 times during the period in question, where's that at? Which box? 2,000 is your total. That's the total number of times she spoke. How many of them were vaticinal? How do you solve? Cross multiply and divide. So we're going to take 2,000 times 932 and divide by 1,000. How many times does 1,000 go into 2,000? 2. So what's 932 times 2? 1,864 were vaticinal. Oh, darn. That's an easy one to calculate. So what did they ask for? How many were not? Oh, man. So up here is where my not is. How can I find my not without having to find this box right here? Yep. If we have 2,000 total and 1,864 were vaticinal, how many were not? Just subtract. 2 leaves 1, 9, 9, and this is 10. So 10 minus 4 is 6, 3, 1, 136. If not, what's 1,000 minus 932? 68. So I could have replaced this number right here. I could have said 2,000 times 68 divided by 1,000. So once again, 1,000 goes into 2,002 times. What's 68 times 2? 136. Same thing we got the other way. So showed you two different ways where you could get that 136. Question. Okay, here's where you're going to need your note card. Got your note card? Taylor, give me a number. 3. What's the next consecutive integer? 4. What's the next consecutive integer? 5. What's the next consecutive integer? 6. Those are 4 consecutive integers starting with 3. What if I told you negative 3? What's the next consecutive integer? Negative 2. The next one would be negative 1. The next one is 0. The next one would be 1. What are you doing every single time to get to the next consecutive integer? You're going up by how many? 1. So here's something that you need to put on your note cards. If I talk about consecutive integers, here's how we represent consecutive integers. The first one I'm just going to let be x, such as the 3 that Taylor picked. What did we do to the next one? To get the next one, we added 1. That's your second consecutive integer. How do I find the next consecutive integer? You add another 1 to this one, but if I add another 1 to this one, what's it actually going to end up being? X plus 2. So your next consecutive integer is x plus 2. Now I'm going to add another 1 to get to the next number, and if I add another 1 to x plus 2, what does that make it? X plus 3. So my next consecutive integer is x plus 3. And that pattern is going to continue. The next one would be what? X plus 4. The next one would be x plus 5. You're supposed to be walking on that? Are you supposed to be walking on that?
I had it with.
Oh, you did when you took a step. Yes, you did. Okay, but what we also have, if I took Taylor's number of 3, and if I said, what is the next consecutive odd integer? 5. The next consecutive odd number is 5. What do you add each time? 2. What's the next consecutive odd integer? 7. And the next one would be 9. And we could continue on. What if I start with an even number? Milo, give me an even number. 4. So if I start with 4, what's the next consecutive even number? 6. The next one is 8. The next one is 10. So I don't care if it's even or odd. What's the difference between each one of those? What do you add each time? 2. You add 2 each time. So here's the next thing for your note cards. Consecutive even or odd integers. There's a difference of 2. So x is going to be your first one. Now keep in mind, x will be even or odd based off of what you are looking for. But to get to the next one, it's going to be x plus 2. If x was odd, like 3, the next one would be 5. If x was even, like 2, the next one would be 4. 2 plus 2 would be 4. What do I do to get to the next even or odd integer? I add another 2. What is x plus 2 plus 2? X plus, what is x plus 2 plus 2? X plus 4. So the third even integer is going to be your even or odd one. So if it was 4, you would add 4 to give you 8. Right? It just means you're adding 2 every single time. So the next one is going to be x plus 6. The next one would be x plus 8. The next one, x plus 10. Now that's whether it's even or odd, correct? X will designate whether it's even or odd when you solve. Just because it says odd doesn't mean I put odd numbers there. I'm not adding odd numbers every single time. Okay, so far. All right, so let's look. Find 3 consecutive even integers. Let's go to a different one first. Remind me to click back a slide, okay? Find 4 consecutive integers. How do I represent 4 consecutive integers? 4 numbers. The first one is x. Consecutive integers, what do you do to get to the next one? Add 1. So the next one would be x plus 1. What's the next one? X plus 2. What's the next one? X plus 3. There are my 4 consecutive. There's my 4 consecutive integers. Now I have to write an equation. As I write my equation, it's 5 times the sum. Do you remember how to show 5 times the sum? Nope. 5 times what? The sum, which means add. 5 times the sum of what? The first and the fourth. What's your first? X. What's your fourth? X plus 3. So it's 5 times is the parentheses. Sum is add the first and the fourth together. Now I got the word is. What does that mean? What's is mean? Equals. And then I got this statement that says 1 greater than. What's that mean? I got to add 1. So plus 1, 1 greater than, 1 greater than what? 8 times the third. So I have 8 times, what's your third? First, second, third, x plus 2. 5 times the sum of the first and the fourth is 1 greater than 8 times the third. Now we solve, no? Because I want to know what are those numbers. So we're going to solve. So if I solve, what's the first step? Do you distribute or do you simplify in the parentheses first? I don't know. You simplify first? Yeah. right? So we have 5 times, in parentheses, what do you have? 2x plus 3 equals, we'll leave it as 8, x plus 2 plus 1. Is the left-hand side simplified? What do you want to do to it?
You want to make it.
Yeah, we're going to distribute. So if I distribute 5 times 2x is 10x, 5 times 3 is 15. On the right-hand side, how do I solve? I distribute. So you get 8x plus 16 plus 1. Was the left-hand side simplified?
Yes.
Yeah. 10x plus 15. Is the right-hand side simplified? No. 8x, I can group these two terms together to give you plus 17. Now what do you do? Move the 15 over by subtracting it. But that means I have to take the 8 and move it over by changing the sign or subtracting it. So 10x minus 8x is 2x. 17 minus 15 is 2. And if I divide by 2, what is x? 1. Now here's where other people mess up. You stop and you circle your answer right there. What did they want? They wanted 4 consecutive integers. What's your first integer? 1. What's your second integer? 2. The next one is 3. The next one is 4. There are your 4 consecutive integers. So your answer is 1, 2, 3, and 4. Just don't say x is 1. You have to list those consecutive integers. Question. Back up one. What's this one asking for? Even integers. So how do we say we represent even integers? X. X plus what? 2. Even or odd integers has a difference of 2. So this would be x plus 2. The next one would be x plus 4. So there's our 3 consecutive even integers such that 5 times the sum. So I have 5 times the sum. The sum of what? The first and the third. So your first is x, the third is x plus 4. First, second, third. What's the word is? Equals. Then I have 16 greater than plus 16. 16 greater than. Then I have 9 times the second. So 9 times, what's your second? X plus 2. Now I'm going to tell you something right now, is that in a homework assignment, it may say the opposite of the second. The opposite of the second is not that right there. The opposite of the second is negative x minus 2. For an example, give me a value for x. 2. 2 plus 2 is 4. If I just negate that first value, then it becomes, what's the opposite of 4? Negative 4. If I just change that x to a negative, you're going to get 0. And that doesn't work. You have to make sure that if x is 2, you get negative 2 minus 2, which is negative 4. So if it says the opposite, I put it out in front of the parentheses like that. Okay. That's going to be on an assignment sometime. But I just want to forewarn you of that. Okay, so we need to solve it. What are you going to do to solve it? Simplify inside the brackets. So I have 5x plus x is 2x plus 4. On the right-hand side, I'm going to go ahead and use that distributive property to give you 9x plus 18 plus 16. Okay, how do I simplify the left? 10x plus 20 when you use the distributive property. And what is 18 plus 16? $34. Now what?
And 20 over.
Move the 20 over, which makes it negative 20, which means I got to move the 9x, making it negative. And you get x equals 34 minus 20 is 14. Is that my answer?
No.
Nope. So we cannot circle it, which is what some of you are going to do. So it says 3 consecutive even integers. Did I get an even integer? Yes, that's what I wanted. 3 of them would be 14. What's your next one? 16, and your next one is 18. There's your answer. 14, 16, 18. All right, questions? Okay, you'll work on the problem set tomorrow and back tomorrow. So you'll have, look at it, see where you can get with it from Monday. Monday I'll take some questions probably. Okay? 6. Since that's 6. I'll tell you the page. So I get my card book out. You keep a hold of 7. I'll pre-check it. You might have 5 turned in already. Yep, just a minute. Let me put the assignment up on the board now.